A ratio is a comparison of two or more quantities. So we can write ratios as, let's say, A to B with the word to in between, a comparison of quantity A to quantity B. We could also write as a fraction, A over B, or A colon B. That's like colons. So this would be read the same way. The comparison of quantity A to quantity B, quantity A to quantity B, quantity A to quantity B. So the way that we would use a ratio is in the example. So for example, at Riverdale High School, there are 120 teachers and 2,000 students. What is the student to teacher ratio? So we're going to compare the number of students, which is 2,000, to the number of teachers, which is 120. And I could have written this ratio any of the three ways. I just chose to do the fraction. And then I just want to make sure that I reduce it as much as possible. So I'm going to take off a 0, and then divide by 2 would give me 100 over 6, and then I'm going to keep reducing that. I can divide those both by 2, 50 to 3. So the student to teacher ratio is 50 students to every 3 teachers. A cookie recipe calls for 3 tablespoons of chocolate chips for every 24 tablespoons of flour. What's the ratio of chocolate chips to flour? So there are 3 tablespoons of chocolate chips for 24 tablespoons of flour, 3 to 24, and then I can reduce that. Those are both divisible by 3, so that would be 1 to 8. So the ratio of chocolate chips to flour is 1 to 8. So the way that we could use this is, let's say I told you the ratio of the measures of the angles in a triangle, because there's 3 angles in a triangle. The ratio of those 3 angles is 3 to 4 to 5. Well, if I take the numbers out of this ratio and stick an x on them, that means one of my angles is going to be 3x, one of my angles is going to be 4x, and then the third angle is going to be 5x. So if I take the 3 numbers out of the ratio and stick a variable on all of them, those can represent the 3 angles of the triangle. So it's kind of like 3x, 4x, and 5x. Those are the 3 angles of that triangle. So we know that if you add up the 3 angles of a triangle, they should always add up to 180 degrees. If I add up the 3 angles of this triangle, they should add to 180 degrees. So I have 3x plus 4x plus 5x. I can combine those like terms to get 12x equals 180. And then I'm going to divide both sides by 12. And 180 divided by 12 is 15. So the measures of the angles are 3 times 15, which is 45 degrees, 4 times 15, which is 60 degrees, and 5 times 15, which is 75 degrees. And then you can double check 45 plus 60 plus 75 adds up to 180. So the 3 angles of the triangle are 45 degrees, 60 degrees, and 75 degrees. Another example, in a triangle, the ratio of the measures of the sides is 2 to 2 to 3. So there's 3 sides on a triangle. So one side is going to be 2x, another side is going to be 2x, and then the third side is going to be 3x. So interesting, this is just a random thought. This is an isosceles triangle because 2 of its sides are both 2x, so 2 of its sides are congruent. So that's just a side note. But anyways, same thing, I'm going to take the numbers out of the ratio and I'm going to stick a variable on them, 2x, 2x, and 3x. Then it tells us the perimeter of this triangle is 392 inches. Perimeter means you add up all the sides. So I'm going to add up all the sides. 2x plus 2x plus 3x. If I add up the three sides of the triangle, that's the perimeter, and it tells me that the perimeter is 392 inches. So 2x plus 2x plus 3x is 7x. And then I'm going to divide by 7 on both sides. 392 divided by 7 is 56. So that means our sides are 56 times 2, which is 112, 112, and then 3 times 56 is 168. So 112 inches, 112 inches, and 168 inches.